I'll show you now an efficient way to multiply. The way that most people have been taught to multiply involves a pattern similar to this, where 7 times 8 is 56. So they would write a 6 and carry a 5. Then 7 times 3 is 21, plus 5 is 26. 7 times 5 is 35, plus 2 is 37. Insert a 0. 2 times 8, 16. 2 times 3, plus 1, 7. And 2 times 5 is 10. Then most people at this point would add down. 6, 12, carry the 1, 15, carry the 1, and 4, and 1. So this process, this pattern, resulted in 3 carries here, 2 carries here, and these two numbers, which to most students don't have an intrinsic value. They don't know if these answers are correct or not, and hopefully when they're finished they come up with the right answer. If there's an error, unfortunately they might as well throw it out and start all over again, and this reduces their math confidence over time, especially if a student struggles with a particular problem and doesn't know where their error is coming from. We will do the same multiplication with much less effort. 7 times 8 is 56. 7 times 3 is 21. 7 times 5 is 35. So notice that I followed the same pattern that we did here, but I gave everybody much more room. I didn't involve any carrying, and I just spaced everyone out in columns. You insert the 0 and proceed. 2 times 8 is 16, 6, and 10. And add down. Now, the answer, grab this last digit and then combine the following digits. 7 plus 5 is 12. Carry a 1. So here we actually carried, but it's a small carry, and we proceed. 1 plus 3 plus 1 is 5. 0 plus 4 is 4, and 1. And we come up with the same answer we did here, but several things are significantly different. We only carried once here. Here we carried 5 times, and we carried significantly larger numbers than we did here. Also, a student can follow their own work and see if an error is made and where an error is made. So if a student has a particularly difficult time with one part of the multiplication tables, that repeated error will be seen throughout this process. Whereas over here, if a student is having trouble with perhaps their 7's times tables, they may not know where their error originated. If we were to, say, insert decimals into this problem, again, there is no real significant difference. So 1, 2, 3 would result in 1, 2, 3. 14.526. So decimals don't make this process any more difficult. Much the same is true for here. Now, a scenario that sometimes causes students confusion is with a 3-digit number. I'll show you in a moment where I mean. So 7 times 8 is 56. 7 times 5, 35. 72. 45. And we add down. Here we come up with 107. So to get our answer here, the same process applies. Take the 6. Only the last digit is taken. 7 plus 5 is 12. Carry the 1. 5 plus 10 plus 1 is 16. Carry the 1. 1 plus 4 is 5. And that's it. Now, smaller multiplications can sometimes catch a student, especially if the first digits are very small, or the ones digits. So 1 times 2 is 2, and 3, 10, and 15. Now, question sometimes pops up, what do I do here? It looks like I'm missing something. And in fact, when the first digit is a single digit, I tell the students to be careful and make it a 2-digit number. This makes sure that they don't push together and add the wrong columns. 0 plus 3, 5 plus 1, and 1. And that's it. Thank you very much.